First of all, Vite covers both the development part and the build part. During development, it is a dev server. And during build, we actually run a full bundling process using Rollup. So if you use Webpack, you have to install Webpack, Webpack CLI, Webpack dev server. Then you need to configure the dev server to do the same thing with the actual build. But Vite tries to just have all these things in one package.
What's up, friends? This episode is brought to you by our friends at Retool, the low-code platform for developers to build internal tools. Some of the best teams out there trust Retool. Brex, Coinbase, Plaid, DoorDash, Legal Genius, Amazon, Allbirds, Peloton, and so many more. The developers at these teams trust Retool as the platform to build their internal tools, and that means you can too. It's free to try, so head to retool.com/changelog. Again, retool.com/changelog.
This is JS Party, your weekly celebration of JavaScript and the web. We record live on Thursdays at 1 p.m. US Eastern, 10 a.m. Pacific. Join in on the hijinks at jsparty.fm/community. It's totally free. And don't forget to follow us on Twitter at JSPartyFM. Special thanks to our partners at Fastly for delivering you our episodes super fast all around the world. Check them out at fastly.com. All right, here we go. Hey, it's party time, y'all.
Hello, JS Party listeners. We have a very special show today, and it's actually extra special because we're recording it at a special hour because our guest is so special. Like, we made all kinds of, there's coffee going on for Nick and I. This is very exciting. So, Nick is my co-panelist for today. Hello, Nick. Welcome.
Hoi, hoi.
How are you? It's been a hot minute since we've been on a show together. I feel like, yeah, right?
It has. How are you doing?
I'm doing great. I miss you, and I'm happy to be talking about Vite with you today with our special guest, Evan Yao. Evan, welcome. We're so happy to have you here.
Thank you. Thank you.
Welcome.
Yeah, happy to be here too.
Yeah, you're like this. For me, you're like this. I don't know. I feel like you're the most. I'm trying to say a word that won't get censored. You're the most prolific, one of the most prolific open source developers for me.
Thank you.
Yeah, really. I think your story and your journey has been so interesting. I think you've gone from working at a big company to kind of working independently for yourself and supporting yourself and creating some really great open source tools while you've been doing that. So can you tell us a little bit about yourself for folks who might not be familiar? And yeah, give us a little bit of your origin story.
Hi, everyone. My name is Evan Yo, and I'm a full-time open source developer, and I've been doing that since 2016. So it's almost 6 years now. Before that, I worked at a Silicon Valley startup called Meteor, and before that, at Google for a bit over 2 years. So I mostly work on two projects, Vue.js and Vite, which we're talking about today. Yeah, and I spent first half of my life in China, second half in the US, and recently just moved to Singapore. So this is the third chapter. And put me in a really awkward time zone for scheduling meetings with US people.
Yeah, it's like we're on almost a 12-hour spectrum here, So it's 9 o'clock for you and
exactly
8 a.m. for me. It's 7 a.m. for Nick. So fun times. No, well, thank you so much. We're so happy to have you here, Evan. And I think for me, one of the reasons why I find your work kind of so interesting is I think you've always somehow managed to challenge the status quo and whip out something that's not only impressive in terms of its ability, but I think in terms of its community as well. Mm-hmm. I think Vue has just kind of we were just talking last week with Toby Langell about kind of open source sustainability and what it's like also for corporations to start drawing all of our boundaries for us within largely adopted open source projects. And, I feel like Vue has stayed true to its community roots. And it's really great to see you've done the same thing also with Vite. So can you tell us what is Vite? So first of all, anyone who's Vite, I thought it's Vite. What's going on?
Yeah, so Vite is the French word for quick. So Vue is in fact also a French word. So
yes,
the technically correct pronunciation would be Vue. But I just decided to go with Vue. And with Vite, I decided, okay, it's a French word. Let's pronounce it the French way. So because I get the opportunity to actually set the record straight off the bat. So this time I'm doing that. But yeah, it's a play on the quick, right? Because the original motivation of building Vite was we were having some really slow build times and during development, waiting for the things to compile. And it's especially for large Vue applications. So I was getting fed up a little bit myself. So I was looking into ways to say, can we make this a bit quicker? When I think maybe this is the thing that'll do it. So I decided to give it a name that has some connection to quick or being fast.
We did a hack week at my work a few months ago, back in November, and we had to do like pitches. And my pitch was, let's replace Create React App with Vite and see how that goes for a week. And as part of my pitch, I was just like, Vite rhymes with feet. And that's how I hammered it in, the correct pronunciation.
Okay.
Vite rhymes with feet. Yeah. So first of all, thank you for even like drawing the lines for me that like Vue is also French. Like I didn't even like make that connection, which is so weird. Like so also you're clearly also waiting on naming, it seems, right? Like so like you got the alliteration going, French connection. French connection, also a clothing store, by the way. It's right. But anyways, so slow build times, right? So can you kind of like walk folks through like what was kind of maybe some of the source of that slowness, right? Because for a long time on the web have not had a native module system. And so the community has put together all of these kind of like variations like AMD, CommonJS, UMD, IFEs, and like, whatever else like we could think of, right? And, ECMAScript 6 kind of like has saved us from that universe, right? So, but it's taken a long time to really roll that out in terms of like, have we been able to really benefit from having unbundled modules in the browser and also in our build system? So can you walk us through like how ESM has maybe saved the day a little?
I would say ESM natively in the browser presented us an opportunity to sort of just rethink how the model should work. Because previously, because we didn't have a native module support in the browser, we have to basically bundle everything ourselves. So that's why we had tools like Browserify, Webpack, Rollup. They're all bundlers because their primary goal is to take your source modules and then concatenate them, also put them into essentially pretend there is a module system and put everything into one file that the browser can understand. And the major downside of this is for every change that we make, even if we just change a single module, we have to still bundle the whole thing because we have to rebuild this whole entire bundle so that we can reload it in the browser. So this essentially means during development, the build speed just deteriorates linearly with the size of your app. The bigger your app is, the slower the build gets. So if you have an app with 1,000 modules, even if you just added a single one of them, you have to wait like 10 seconds for the thing to build. And it just gets worse and worse the longer you work on a project, right? So that's why we start to have concepts like hot module replacement. But interestingly enough, even if we did have hot module replacement with Webpack primarily, so we discovered that I'm not entirely sure the actual reason behind it, but what we found in the wild is that hot module replacement performance also deteriorates the bigger your app gets. And that's very common in large Webpack-based projects. So I don't want to say that like Webpack is the cause of this problem because it's a pioneer in actually bringing the concept of bundling mainstream, right? The thing that we noticed is because our toolchain for Vue, called Vue CLI, was Webpack-based. And Vue single file components also have some pretty intensive compiling involved. So when we have a large Vue project, it can still take like 4 to 5 seconds, even if you just added a single file, and then for the hot module replacement to happen. And for me, that really kills the feedback loop, the overall flow when I'm working on something, because I'm just making a simple tweak. I have to wait 5 seconds, and it just like, during that 5 seconds, my mind gets a hold of something. Maybe I see a message, see a Twitter message or something, then I just get distracted. The longer the feedback loop is, the more chances that you get distracted or you just lose your flow state when you're working on something. So I was really wishing that I could find a solution that gives me that really instant, snappy feedback loop when we first started working on the web, because you just load a script into an HTML file, you refresh the page, you just refresh, everything just reloads, right? You don't have to wait for things to compile. So native ESM kind of gives you that really snappy thing, right? You just write native ES modules, the browser can handle it. It's really fast up to a certain point. There is some interesting technical limitations we can talk about later. But for most apps, if you're just loading maybe 100 modules, the speed is very, very good, especially during local development. So combined with that is if we also rethink how hot module replacement can be implemented over native ES modules instead of over a bundling model, we can decouple the hot module replacement performance from the size of our app. So no matter how many modules you have in your module graph, if you're editing just a single module, only that module and the import chain that imports that module should be invalidated. That's the ideal situation. And that's what Vite's hot module replacement is able to do. So that keeps the hot module replacement speed constant, even if your app is really huge.
Yeah, that was a really great summary of the benefit of moving from this linearly growing build time to kind of the benefit of just, everything is modularized. And so even the hot module replacement is able to be more optimized and so this really makes a lot of sense. So Evan, can you tell us a little bit about how you were able to also leverage ES Build to handle some of this heavy lifting?
I talked a little bit about the limitation of native ESM, and the limitation is it struggles a little bit when you have too many modules loaded in the browser. Let's say when you're loading 100 modules, it's snappy, it's fast. But once you do something in the thousands, it just starts to congest at the network level because the browser has to make a HTTP request for every module that's fetched. So when you have too many modules being fetched in parallel, the browser just gets stuck a little bit. And you kind of have this sort of waterfall of waiting for the request to come back. And we noticed that there are two aspects to solve this problem. The first is because ESM is loaded on demand, right? So if you do code splitting, say you lazy import certain parts of your app, which we should do in production for better performance, right? For our users. It turns out that would also improve your local development performance when you're using native ESM, because now you're only loading the modules that you're actually working on. Say if you have a big app with 20 routes, but you're only working on one screen, and if each route is lazy loaded, then even during development, you're only loading and compiling the modules that's on the route that you're currently working on. So that's one aspect of it. So we really actively encourage our users to think about code splitting even right when you're developing, because that affects both development and production performance. The second aspect of it is a lot of these dependencies. For example, when you import Lodash, so Lodash has an ES module build called Lodash ES, but it has 600 internal modules. So when you import Lodash ES directly, the browser makes 600 requests all at once, and it just goes crazy. So one thing we noticed that is because these dependencies are almost always guaranteed to be plain JavaScript, there's really no special transform logic that you need to do about them. So we go back to the bundling route, but we sort of pre-bundle them. So this is where Vite tries to be smart, is it separates your source code from your dependencies, because your dependencies don't change often. Second, they're almost always plain JavaScript. So we pre-process them. Each dependency gets pre-bundled into one file, and we do that with ESBuild. So this is where ESBuild comes in. So ESBuild serves multiple roles in Vite. It's a really great project. So we first use it for dependency pre-bundling, as I said. So this allows us to squash, for example, Lodash ES from 600 modules to just one module. So now it loads snappy. It doesn't create all these extra requests. And because ESBuild is extremely fast, and what we noticed that is a lot of time is actually wasted in large projects, a lot of time is wasted when you rebuild a project. It's actually just building the dependencies over and over again. If your dependencies version didn't change, why are you rebuilding it over and over again? So on your first server start, Vite will pre-bundle your dependencies and then cache them. So on the next server start, if your package dependencies, your lock file didn't change, we'll just reuse everything.
Just caching.
We don't need to do any work again. You just cache them, right?
Yeah, that makes a lot of sense. I worked with someone who worked on the a Webpack plugin. I think it was Webpack Cache. We'll put it in the show notes, but it was
DLL plugin.
Yeah, it was a plugin that helped optimize your Webpack build time and rebuild time because it just cached all of that. It did a lot of caching. And I think that was it ended up being the base spec for how Webpack handled perf in V4 or something like that, right? They kind of took that model from that plugin.
Yeah, file system caching is obviously going to be a big performance boost. But the thing is, in Webpack, because everything is bundled together, essentially how your code imports dependencies would affect how the dependency should be bundled. So changes in your source code would actually invalidate the cache for your dependencies in some way. So in Webpack, if you want to really consistently cache your dependency build result, you have to use something like the DLL plugin, which is pretty complicated to configure right. So one of the things that we also kind of struggle with is you can do a lot of very advanced optimizations with Webpack, but they are very, very hard to get right. Also, the more of these advanced plugins or configurations that you use, the harder it gets for you to get everything working together nicely. Because we maintained Vue CLI over a very long time. And Vue CLI is sort of this battery-included Webpack-based solution. We try to do most of the complicated stuff for our user. And during that process, we absorbed so much complexity, it's just getting out of hand. While working on Vite, I also tried to learn from the things that we learned during the development of Vue CLI to say, okay, where is this step where maybe we can drop down to the right layer of abstraction, directly in the tooling itself, to solve some of this complexity problem, instead of having the base tooling to be extremely configurable, but then the configuration layer becomes extremely complex. How about we just collapse these two layers together so that we solve the complexity directly in the tooling, so that we make the higher level system much simpler?
So a question I had about the assumption that you make on dependencies, and I'm just wondering how Vite handles non-JS dependencies, because a lot that I can think of is maybe Tailwind classes and CSS or SVGs, things like that.
I see. Mm-hmm. There are two ways to deal with this. The first is for assets like CSS or SVG. When you import them, we externalize them during the pre-bundling phase. So those files will essentially be preserved and then go through the same plugin pipeline as your source files. The second way to do it, for example, if you have a package that is shipping directly, say, Vue files or Svelte files, you can use the configuration option to say, don't pre-bundle this. Just load this as normal source files. So all those files will go through the same plugin configuration as your source file.
Yeah, I mean, I think for me, what was so cool about Vite was I think there's hindsight factor, right? We've been bundling and doing complex build development locally for a while now, where we've been able to kind of modify on some really big pain points in our community, right? You've named some of them around build time and optimization of our module loading and lazy loading, right? But also I think there's stuff just having CSS support just work, and then TypeScript support just work, right? So I mean, we're starting to kind of it feels like we're moving a few layers up on our abstractions, where the community seems to generally be synthesizing on these best practices. So let's in Congress move up a few layers, right? So we can spend more time focusing on the core problems that you need to solve for your app versus twiddling with your Webpack config, right? Because, and this is not a show where we're poo-pooing on Webpack, we're all standing on the shoulders of giants, right? Webpack helped enable us to like learn so many different things, right? And so now we're just like doing what we do as web developers, you know, and just kind of like take the pain points and like innovate on those like cow paths a little further.
But that's just it. Like working within those cow paths and really optimizing for that, because that is in a lot of ways like the general way to do development now. And so you can build on top of that and just make those assumptions and keep things a lot smoother for the general use case, which is just so nice.
Yeah.
I'm the same way as you, Evan. If it's taking a couple of seconds to build or to like refresh, my mind just immediately wants to go somewhere else. And so like the hot module replacement is amazing, especially like when I've been working on a multi-part form component for a long time. If I could have it automatically refreshed at the part of the form that I'm at, instead of having to restart every time and go through it, that makes such a difference. And so it's so nice. That's why I was a big fan of like AMD back in the day, because it just immediately reloaded and the browser understood it.
Yeah, in some way, I think when Vite first came out, people were joking like, "Isn't this just like AMD back in the like Require.js back in the days?"
Well, history does repeat itself. I think we had a talk with Rich Harris like a few weeks ago, and I think we kind of circled on no pun intended. We circled on like this. We're not doing a full circle necessarily. There's a pendulum swing happening, but it's a progressive one, right? It's like we're pendulum swinging, but we're continuing to progress and go up,
What's up, party people? This episode is brought to you by our friends at Raygun. Raygun gives you instant visibility into the health of your software. Get actionable real-time insights into the quality and the performance of your web and mobile apps. Raygun delivers modern tooling for customer-centric teams, error monitoring and crash reporting, ship better quality software faster, get code-level insights into the health of your application in real time, and start fixing the errors impacting your end user's experience. You get real user monitoring, quickly identify and resolve front-end performance issues impacting real users in real time, understand exactly how your application performed for every user session and page load. And of course, application performance monitoring gain unrivaled visibility into server-side performance, unlock detailed code-level insights into the root cause of performance issues so you can take action and deliver lightning-fast digital experiences. The next step is to head to raygun.com and start your free 14-day trial, no credit card required. Join thousands of customer-centric software teams who use Raygun every single day. Again, raygun.com.
So we talked about Vite and kind of introduced what it is and what it does, but let's talk about where it fits into the tool chain. Like, what if you replace your current build system with Vite, what are you actually replacing? What are the nuts and bolts of it?
Yeah, so first of all, Vite covers both the development part and the build part. So it's during development, it is a dev server. And during build, we actually run a full bundling process using Rollup. So if you use Webpack, right, you would have to install Webpack, Webpack CLI, Webpack dev server. Then you need to configure the dev server to do the same thing with the actual build. But Vite tries to just have all these things in one package. So when it comes to the modules, it handles TypeScript out of the box using ESBuild. So it only transforms the syntax. It strips away your types, spits out plain JavaScript. It doesn't do type checking. One of the reasons we do that is because TSC type checking is really slow. So having that to be part of the module transform pipeline is actually a major performance killer. On the other hand, if you use something like VS Code, your VS Code already runs a TypeScript language service, and you already get all these type checking while you're working on your code. So why would you want to do it as part of your build process to just slow it down?
Seems very redundant. Yeah.
Yeah, right. For those who really want to have type checking during development, like on your command line, we also have a plugin system. Like the community has come up with plugins that allow us to just run TSC in a separate process, so it can leverage multiple cores without making your whole build pipeline slower. I think that's also a better model than doing type checking as part of a module transform. So that's TypeScript. And because ES build is extremely fast, you don't really notice a difference when you just you can literally replace all your JS files to TS and the build speed will be the same.
Nice.
That's really powerful.
Yeah.
I think for me, what's lost on some developers is that TSC is good for type checking. And I would say transforming that into JavaScript, it can be a whole other separate process. And that's typically best done with Babel because Babel, I think, is a better transformer than, the TSC compiler. And so it's good to kind of split those up if you can, where you just use TSC for types and Babel for transforming. So I'm curious to see what else, where does Babel even fit into this, this world?
Yeah.
Evan? What decisions did you make? Let's put you on the spot.
Yeah, so by default, we don't even need Babel anymore if you're building a Vite app. So the default assumption, the target browser support is modern browsers. When you build with Vite, the output is, in fact, also native ESM. So it assumes your browser already supports native ESM. You can support older browsers, but that requires using a dedicated legacy plugin. So the legacy plugin will, in fact, pull in Babel using Babel preset env to actually do all the transpiling, down leveling your syntax and all that. But if you are targeting above ES 2015, ES Build already does a lot of the syntax down leveling. So if you're targeting modern, you still don't need Babel. So Babel really only comes in two scenarios. One is you're really targeting legacy browsers. And two is you need to do really custom plugins, completely custom Babel plugins. That's where Babel plugin. Another case where Babel plugin coming is if you use React.
You're using non-JavaScript, I'm using stage 2 and stage 1, right?
Yeah. You want to get those early proposals in. You can use Babel, and you can directly use Rollup plugin Babel because Vite is compatible with most Rollup plugins. So you don't even need to look for a lot of things. You don't even need to look for a Vite specific plugin.
Nice.
You can look at the existing Rollup ecosystem, and we also have a page where it lists all the compatibility of existing Rollup plugins with Vite. And I think we cover all the official plugins. We maybe cover 80% to or more of them. So yes, you can use Babel if you want, but if you're targeting modern browsers, the chances are you don't really need to.
There was another use case that I found in my week with Vite, and that was if you are relying in any way on the actual code being I don't even know if I'm saying this right, but would Babel essentially be treating that code kind of like CommonJS and then it's transpiling it to not ES modules, right?
I'm not sure if I...
So the specific use case I'm thinking of, and one way that we ended up having to use the Babel plugin for Vite was specifically for our tests. And that was because we were using just.mock and we needed to be able to get into the module loading to replace modules with mocks.
So are you using Jest?
Yeah.
Okay. So using Jest with Vite has always been a bit awkward because...
Yeah, Jest has opinions.
Yeah.
Just has loud ones.
Jest didn't really have native built-in async transform support. So for a very long time, we're completely blocked on that. So I think in Jest 27, they finally shipped it. So now technically, we have a first-class integration with Jest. But still, it's sort of non-optimal because Jest really is people using Jest are very used to configure a completely separate set of transforms just for Jest.
Right.
Which in a lot of cases is redundant. And you have two configurations, two different set of plugins for two systems. So that's why the community came up with a project called Vitest.
Yes.
And it's a Vite native test runner. It uses Vite itself as its transform pipeline. And it uses a lot of Vite features it reruns your tests almost like hot module replacement. It can even directly read your Vite config file and just use exactly the same config. So you just have one config file and it just automatically do the exact same thing as your source files. So when Vite first came out, unit testing was a major pain point for a lot of our early adopters. But I think with Vitest, it's really a solved problem now. In fact, Vitest can be used even in non-Vite projects. We've heard a lot of people just migrating from Jest to Vitest without even using Vite. And they found their tests to be running much faster.
Nice.
Yeah, and they're probably maintaining less configuration as a result too. Yeah. So Evan, I just kind of want to go back to the Babel point because I think, I find Babel, so just because an ECMA standard gets published, like ECMAScript 2022, if it gets published, right, or 2020, 2019, just because the standard is published doesn't mean it's actually universally implemented in all modern browsers either, right?
Yeah.
So Babel Env, or Babel preset Env, essentially kind of help manage that matrix of hey, you're targeting the last 2 versions of every modern browser, no legacy browsers. Yeah. We know which browser supports what, and they maintain this real-time check. And so where does that come into play? Because I feel is there an equivalent of that in the Vite ecosystem?
Oh, yeah. So first of all, ESBuild covers that to a certain extent. So ESBuild, when we do our final build, production build, we do have an option called build.target. You can say target ES 2015. If you set that target, then all the syntax that's above ES 2015, ESBuild will down level that. For example, if you use object spread, but you target ES 2015, ESBuild actually handles that for you. It will inline a helper for you, sort of like Babel helpers, and then transform your code directly. Which is why I say, if you target ES 2015 or above, in most cases, you don't really need Babel. For production build, that is. The other aspect of it is, my personal preference is, when I'm, say, developing, I don't know, maybe I'm able to just, when I'm using some features, because I work on Vue, as a library author, I kind of just memorize all the which ES edition has a certain feature. So I'm always trying to remember, okay, this is our browser baseline support. I can't use this. I can use this. I cannot use that. So I'm getting used to that. But yeah, I realize for
average everyday people, for the rest of us average folk.
Not average, but for most developers.
Yeah, no, I know what you mean.
For people who work on applications, right?
Yeah.
You don't want to really just have to remember which feature you can use or not use. So you want to leave that to the tools. So I'm glad ESBuild does that. But if you want to go even lower than ES 2015, then Babel preset env obviously covers that for you. I think SWC also replicates Babel preset env. So we, in fact, have users in the ecosystem to use SWC as a Babel placement in certain cases as well.
What is SWC? I've seen it floating around in the ecosystem. So I feel like I know what it is at a high level. Do you want to just maybe explain that to our listeners?
To put simply, it's sort of like Babel, but written in Rust.
Yeah, it's a good segue to our Rust.
It's more opinionated than Babel. You can write plugins, but you can only write plugins in Rust. So it's a bit harder to extend for normal JS developers. I haven't been able to write a SWC plugin myself. But from a conceptual level, it does the similar things. It parses your code, transforms the AST, then spits out JavaScript.
Yeah, I mean, I say for me, it's just if we're pegging against ECMAScript 2015, we're also holding the web back a little, right? Because there's some things that are newer that would be supported in some browsers universally across newer standards, but
I would love to peg against ES 2015, to be honest.
Really? Okay.
Until June, when the end of life of Internet Explorer comes, I'm still on that train.
Yeah.
We were just holding the web back, yeah.
I personally think it's an interesting trade-off because for a Vite-based build pipeline, Babel is in fact a pretty heavy dependency to add into it. Because without Babel, just by adding in Babel into a production build pipeline, you could slow down your build by 30% or 40%. So when you have that in mind, I'm if I can get 30% faster builds by just not using stage 2 features, I'm all for it.
I actually have numbers against that. With Create React App in Babel, our biggest app in a monorepo took 2.5 minutes to build. When we replaced it completely with Vite, it went down to 22 seconds.
Wow.
And then when we replaced it with Vite with the legacy, the Babel plugin for it, it went back up to 2 minutes and 20 seconds. So we've got about 10 seconds faster than Create React App, but it was still majorly slow.
Yeah. It's mostly because preset env is a very, very intensive set of transforms. It just does so many things. It has to do so many checks. That's where really it slows things down. Yeah.
Yeah, and so like we have like this like turnkey experience for the most part if you're targeting, modern browsers, which is like great. And then you have JSX support out of the box, and you have CSS processors support like out of the box. And then you can import web workers easily, and you can like import WASM files. Like, whoa, there's just so much. Who are these developers who are like using WASM and web workers and like JSX? So, like, I want to know these people, because like I'm just like, we need to get them on the show. Tell us about your apps.
Surprisingly, there are a lot of people using these.
I would just meant all together, but yeah, I know. Like in isolation, I think, yeah, for sure.
Yeah. We just recently had to rework our web worker support because I think it's someone from Google tweeted about like, I really like Vite, but the web worker support is kind of using a custom query string, which I don't like. I kind of want to mention Parcel, which is another bundler project, build tool project. So Parcel is actually the first build tool that comes up with this sort of battery included, everything works out of the box concept.
Yeah.
So when Parcel first came out, it was the zero configuration build tool. In a lot of ways, the philosophy of like assuming that certain things should work a certain way and make it work out of the box, this philosophy really aligns between Vite and Parcel. So I just want to give a shout out because Parcel is obviously the first tool to do this kind of thing. So a lot of people who like Vite also likes Parcel for the same reason. And they recently rewrote a lot of their internals with Rust. So it's also pretty cool to check out. Parcel 2 is a really impressive project.
That's a project that I feel like I wish I've had a chance to like play around with, because it's really like just following it. Like I feel like they've always been pushing the boundaries of like how things should work. Like the thought leadership and like North Star, I think, has been with the Parcel implementation and APIs. And so yeah, we'll have to maybe have them on the show sometime. But so I guess like specifically like with this WASM, workflow, I mean, this is just really cool. So can you tell us a little bit about how this works? So essentially we're able to import WASM files.
Yeah, it's really a simple transform because we don't do all the magic. So when you manually do a WASM file, you have to fetch it yourself, then you instantiate WASM instance. So it's basically a lot of grunt work whenever you want to import some WASM into JavaScript using just native web APIs. So we try to give you some help at the syntax level. So when we see that you're trying to import a WASM file, we just transform into the code that you would write manually of instantiating it, then doing certain things.
Okay, I see.
So it's all just build time transforms.
I see. Okay, that makes sense.
But still using web native APIs.
Right. I guess it's maybe a similar pattern for web. You essentially, do you handle like the instantiation of the worker?
Yeah.
Interesting.
The other part about workers is you want to apply the same transforms on your workers as your other part of the code. For example, you want to write your worker with TypeScript.
Right.
You want to have module imports. Maybe you have a worker, but you want to have multiple files that imports one another. But some browsers don't support module workers yet. So we have to pre-bundle the worker for you so that your worker would work everywhere. That's a lot of these kind of things that we do under the hood. So you can have a simple syntax, just import the worker and then use it without having to worry about, okay, how do I transpile the workers? How do I bundle the worker and all that stuff? But
like, you know how like workers have all these special rules?
Yeah.
Because they're running in a specific context. Like I'm curious, like, is there like a lint package or something along those lines that in Vite for like handling all of the rules around workers?
Yeah, Vite doesn't really do that for you.
Okay.
We've actually had this thing where you can use TypeScript to essentially use a different tsconfig for your worker files.
I see. Okay.
So you get rid of the global APIs that you shouldn't have access to in that part of your project.
Yeah, I feel like that's the thing with workers that always trips me up is like, you just always need to make sure that like you're not doing certain things. And I always find out the hard way, like, so just like, we just need some linting rules, I should probably research that.
Yeah.
I'm sure it exists.
Shout out to a cool project called Party Town.
Oh, yes, Party Town. They're the third-party scripts.
Yeah, but they basically created a way to run code in the worker, but still have access to the normal browser APIs.
Yeah, they're on my list of people who I really want to actually interview, because I mean that project is the most creative that I have seen in a very long time, and I don't know how that it's like black magic to me. How does that even work? I don't even know. What are they how are they doing that?
It creates a proxy object that simulates the browser. So every operation that you call, they buffer it into a series of commands, then send it to the main thread, do the things, then send it back. Yeah,
so this is where proxy is probably also one of the least understood but also most powerful built-ins in JavaScript, right? You have to.
It's extremely powerful.
So powerful. Oh my gosh, yeah. Probably do a whole show on proxy. So we talked a little bit earlier about a rollup config being supported with Vite, and I'm assuming obviously all the tree shaking happens as well. So can you kind of talk about this decision to kind of support rollup? There's some intentional kind of steering I think you're doing, but with that's an opinionated move. I think a good opinion, but it's opinionated nonetheless. So
initially, obviously, if we could, we would want to do the bundling with ESBuild because it's just so fast. But the thing is, I tested with that. But the thing is with ESBuild is that it's great for bundling libraries, but it's still kind of a bit immature when it comes to bundling applications. Because when you're bundling applications, you have a different layer of concern that is code splitting, chunk hashing, and how to best optimize your chunking so that you get the best loading performance in production. So in that aspect, Webpack gives you the most control, but it's extremely complicated. Again, it's really, really hard to get a good default. You have to learn how Webpack chunk splitting configuration work. So Rollup gives you less control, but still enough for most common cases. The more important part is Rollup makes it easier for us to sort of give you a good default out of the box, whereas ESBuild gives you almost no control in terms of chunking. So when it comes to the final production build, we basically were facing this decision of, should we just go with ESBuild directly, or should we go with Rollup, which is more mature for application bundling? At the same time, there's another advantage is that Rollup has this already huge existing ecosystem. And personally, I also really like Rollup's plugin API. It's a very concise, simple, but also very powerful plugin API. When I was writing the Vue single file component support for Rollup and Webpack, the Rollup implementation is just so much easier to understand, even for myself. So I felt like a good plugin API is also really important for a build tool, because essentially, the out-of-the-box features designs the baseline experience for all users. But how good the plugin API is decides the ceiling of the user experience. So one reason that a lot of advanced users also like Vite is because they can pretty much do anything they want by writing their own Vite plugins. So they're not even though a lot of things are opinionated, they work out of the box, they can still sort of bend Vite to do what they want Vite to do by writing their own plugins. So I think this is extremely important for power users, right? So having good defaults appeal to the maybe 80% of the users who just want to get things working. But at the same time, there will be this group of power users who want to do advanced things, and you need to give them that ability to do that with a nice API. So I think Rollup's API is a good way to give them that power, and Rollup itself is also, powerful enough for us to give normal users a good default for production performance, and then it has a great ecosystem. So going with Rollup is essentially a sort of a trade-off decision between the plugin API friendliness, the existing ecosystem, and how we can give a better production build performance out of the box for end users. I would say the reason we choose certain lower level tools to do certain things is not always fixed in stone for Vite, because our goal is to have a coherent package to do things. So if, say, there is a Rust-based alternative that can replace Rollup, but is much faster, but gives you the same ability, can be compatible with Rollup plugins, then we can switch to that. I know someone who is working on a Rust-based version of Rollup.
Oh, wow. Yeah. So this is a really great segue into like what I want to get into next around like Rust and where this fits into the ecosystem. I mean, and so there's lots to discuss. I'm also eager to hear about like the server-side rendering story for Vite and all that. And then also I want to hear about your wish list. Like, if like Evan could like wave his magic wand, like what, what would you want to change or what would you want to do? And what would you want implemented? Or which issue would you want closed, So, so yeah, I know we're going to, there's too many.
Too many.
This episode is brought to you by SignalWire. SignalWire offers APIs, SDKs, and edge networks around the world for building the realest real-time video and video communication apps with less than 50 milliseconds of latency. They use WebSockets to deliver 300% lower latency than APIs built on REST, making it ideal for apps where every millisecond and responsiveness makes a difference, like apps that need instant natural language understanding, real-time machine vision, or large-scale video and audio conferencing. Here's what makes them different. They use MCU, multi-point control unit, that mixes all video and all audio feeds on the server side, and then distributes a single unified stream back to every participant. That way, every participant in the apps you ship experience the same video and the same audio. Your apps have none of the awkward audio effects, obvious lag, and jumpy video. It's all smooth, great UX, creating a more lifelike virtual experience without compromising audio or the video quality. Head to signalwire.com/video, mention JS Party to receive an extra 5,000 video minutes. Just go to signalwire.com/video and remember, mention JS Party to get those extra 5,000 video minutes.
All right, Evan. So that was like a really impressive and exhaustive rundown of Vite's capabilities. It was not so Vite, but actually, Vite list was not so Vite. I don't know. All right. Bad joke. Either way, we've covered I think a good chunk of I would say some of the highlight features, but really there's so much more. And I encourage everyone to check out your awesome documentation because really it's quite impressive how rich and robust and well organized your docs are. I just wanted to say kudos to you and your team.
Thanks.
Good documentation is so difficult for open source projects because there's so much bias, as a maintainer on the other side, right? So I know that I don't know if Chris is still helping out doing docs, but I remember there was a few people on the Vue team that were helping with Vue docs. So I don't know if you've got the same thing going with Vite, but
yeah,
it's a beautiful, beautiful website. So
we do have a team. So after I wrote the initial edition, most of the later edits were just made by the team. And we also have PRs from our users too.
Oh, that's great. Yeah. So thank you for pushing that envelope. And I think, I'd love to kind of get into server-side rendering and what that story is, because that has typically been, I'm curious to see if Vite has smoothed out those edges.
Yeah. So for server-side rendering, the first thing is if you were doing it with Node, right, your code needs to run in Node. The challenge is for a lot of apps, for a lot of projects, you have to compile your code differently when you're targeting either a client or you're targeting the server. So there are different code paths. Some code you want to only run in Node, some code you only want to run on a client. And then there's also, for example, for Vue or Svelte, we actually compile our components differently when targeting client or targeting SSR because we, in fact, compile our components into more efficient string concatenation when we're doing server-side rendering. So this means for the same set of source files, you actually need to have two different compile outputs so that you can do server-side rendering. Previously with Webpack, the most frameworks do it in a way that you actually just bundle, make two bundles simultaneously. So every time you edit something, you rebuild the two bundles. And that gets really complicated and is also kind of slow. So when we're thinking about server-side rendering with Vite is we want to have this same sort of snappy instant update, even for the SSR. The idea actually originally was first conceived by Rich Harris. So Rich was working on SvelteKit, So he made this very early version of a transform that can take an ES module file, then rewrite it into something that can be instantiated in Node.js in memory, basically creating a sort of virtual runtime for ES modules in Node.js.
Wow, that's wild.
Yeah.
This is pre ESM support in Node, right? Before there was a path for
I'm not sure. Probably native ESM was already in an experimental version of Node at that time. The thing is, we have different requirements. We can't just use native ESM because we want to be able to precisely replace and invalidate part of that module graph.
Oh, right.
When you edit files. And you can't easily do that with native ESM. So we need to control the module graph, which is why we have to do this ourselves. So Rich came up with that idea first. When they were working on SvelteKit, he heard that idea into Snowpack, which is another
no bundler
build tool with a very similar scope to Vite, right? We were sort of competing because the two projects actually came out around the same time, but with kind of different design decisions on some parts of how we handle depths and how we handle certain things. So Rich was investigating how which tool he wants to base SvelteKit upon. So as a test, he PR'd his SSR module transform into Snowpack. So I saw that and I felt this is a genius idea. So essentially, I implement the same thing in Vite. And the cool thing is we are able to apply the same client-side plugin pipelines on that node-side module as well. And in order to do that, we had to extend Rollups plugin format so that you can use the same plugin to do different transforms based on whether you are doing SSR or not.
So do you have a little abstraction layer in there?
Yeah. So essentially, we took Rich Space Transform, then we combined it with Vite's plugin system and got it to a state where you can essentially use it quite smoothly to run arbitrary SSR for any framework. So we can do that for React, we can do that for Vue, we can do that for Svelte.
Wow.
So it's generic enough, but also, so I think that's also what I'm kind of proud about with Vite is we try to find the right abstraction boundaries so that we do just enough inside the framework so that it's still flexible enough to support different other frameworks like client-side frameworks. But for the client-side frameworks, we do so much that they can basically all share the same underlying implementation without duplicating work with one another. Which is why I think we are seeing a lot of other frameworks like Solid or Markle. They're able to do their service-oriented implementation using Vite as well. So I think that's super great because we have this common foundation that can be leveraged by different client frameworks to do, so they don't have to reinvent the wheels all over again. So I think this sort of is, there are ideas coming from different places, and Vite came up with the most usable, sort of flexible but still powerful enough solution for people. So a lot of these higher level frameworks start to sort of gravitate towards that as the common base. And SvelteKit is now also based on Vite, so using this same SSR system. We also have Hydrogen, which is the new React framework by Shopify, which is also using Vite SSR.
Wow. Yeah, I mean, it's amazing to see all this convergence of ideas, and it kind of came full circle. Rich PR created this thing, implemented it in a Snowpack, which is used by Astro, and in that other ecosystem, and then Vite, and then now SvelteKit is using Vite. It's just coming full circle in a way that's very interesting. So I'm curious, so you can still use all the plugins, and you can still use all of the same plugins that you would if you were just doing a client-side rendered app, in this SSR workflow, right?
Yeah.
Okay, but you're just leveraging this virtual in context where you're replacing the module in memory, in the module graph in memory, essentially.
Yeah.
So is there a limit? I'm just curious for gigantic applications, just think a really complex app, like something from Walmart, for example, right? if Walmart started using Vite, like would they be able to do it on like a MacBook that doesn't have a ton of memory? Like, or would they need, like, what are the constraints there?
They probably could, because technically the way we instantiate these modules wouldn't be more memory intensive compared to native Node ESM. It's really just instead of Node instantiating those modules, we're just letting V8 instantiate it as function scopes. Technically, we don't really incur more memory usage.
Okay. Yeah, this is fascinating. I mean, we'll try to like link to either this part of the code or maybe the PR or anything. Like, we'll try to get some info from Evan, and for folks who want to dig into the specifics of this, but this is fascinating. I feel like it could be its own show. And so SSR support out of the box for multiple frameworks, that's huge. I mean, and fast SSR, like for local development specifically. Very, very exciting. I don't know. I mean, you haven't said the word TypeScript yet, so we haven't heard from Nick, but I mean, I can see Nick's, Nick, that's his magic word. You have to say the word TypeScript. Like, you know, he'll be like, did somebody say TypeScript?
To perk up immediately.
Yes, immediately. But yeah, Nick, so anyway, so we're moving on to kind of some of this other stuff that we covered around like Rust, right? So we've seen like this interesting shift in our community towards like, hey, JavaScript build times are taking too long. Like we need to go lower, closer to the metal. We need to use Rust to like speed that up. Quite frankly, like it's working, right? Like things are faster with these Rust binaries. For me, I worry about the trade-off. And this is probably me just maybe, I don't know, being like grandma and cranky about it. But like, I just worry about like, you know, the trade-off that we're making with just shaving a little bit of time here and there. Like we're also losing like our interoperability and ability for people to contribute and know what's going on and debug, et cetera. So I'm just love to hear like your thoughts on that.
Yeah, I definitely share a concern. I've actually argued with people about this on Twitter because I think there was an article basically saying like Rust is the future of JavaScript tooling, and I was expressing the same concern pretty much. I'm saying, okay, so Rust is fast, but it's harder to write. It's harder to understand, and especially if you have a Rust-based dependency, I can't just crack open Node modules and see what's going on. I can't patch it myself on the spot.
You can't debug it.
Even if I look at the source code, there's a good chance that I can't figure out how to fix it. So when you think about Babel, the reason Babel became so successful is because people can write plugins for it. And you can actually try to, if you already know JavaScript, then you can try to read its guide and understand how plugins work. But performant coding Rust is not easy. So the author, incidentally, the author of SWC, who should be a very, very advanced Rust developer, he was trying to re-implement TypeScript's type checking logic in Rust. And he gave up because he was like, this is just too hard in Rust. The way the TypeScript's own code base works, TypeScript is written in TypeScript, I think, right?
It is.
It is type safe, but it still uses a lot of these dynamic features of JavaScript where you have like these sort of dynamic references between different parts of your code bases, data structures that reference one another. And this is what Rust doesn't like. Rust is like, you need to be very explicit about what memory you want to put where. You need to have the life cycles, like don't just like link things everywhere. And if you use unsafe, it's like, oh, no, like your code will be unmaintainable.
I think I saw this tweet or maybe a similar one where they were talking about like re-implementing the TypeScript type checker in another language like Rust or something else. And it really came down to like somebody got like a base set of features from TypeScript working, but the TS team like chimed in and it's like, well, try generics. Like generics just won't really work.
Yeah, there was a subtweet from the TS team member, I remember saying like every couple of months, someone would write a new cache implementation that's like 30 times faster than Memcached and ask like, hey, can you use this for Amazon? and the Amazon cache team is like, no, like, does it do this? Does it do that? I think it's an interesting challenge. I'm pretty sure like given the the right people and the enough effort and investment,
Yeah.
you can definitely do that. But the thing is, like, Microsoft probably has that resource, probably has that expertise, but they're not doing it. And they're probably not doing it for a reason. That said, I do agree that the speed of type checking is slowly becoming the only major bottleneck of development speed, right? Because syntax transforms is relatively easy, especially with Go. Like ESBuild already, like people argue over whether Rust is faster or Go is faster, but I mean, as you can see, SWC and ESBuild, they are comparable in terms of raw speed when it's just transpiling or bundling stuff. This thing is relatively easy for native languages, and they can do this extremely fast. I think that the complexity of TypeScript itself is not just like type checking itself is complex, but also you need to replicate what TypeScript is doing right now. And a lot of that has historical reasons, like historical burdens. You need to basically do everything TypeScript does in exactly the same way, and then you have to play feature catch up.
Yeah.
And I think that's extremely difficult.
It seems like a losing game, honestly. Like, where, like in the sense that like it's never going to be perfect, and you're never going to be caught up 100%, and also just
Yeah.
That is kind of the big bottleneck right now, but it is another use case for just relying on type checking like in your editor. At least it's kind of like it is a little slower, but it is async. So I can like move on to the next line and it will just ping me, oh, something's wrong here.
Right. It doesn't instantly block you
Right.
from keep thinking about your code.
Yeah. I would agree with you, Nick. That's a really good point. But also, like, I think for me, there's a deeper separation here that we need to kind of like, I think about more broadly, which is like that our types never run in production, right? So like also, like, this is a development aid and it's a build time check. And I think we should start thinking about those two things as separate, because like when we're trying to optimize our developer workflow and like take on this, and like a couple of the concerns, like a little, like it gets a little muddy, right? Especially because like, God forbid, like if TypeScript isn't the hot thing in 2 years, like what then, we're stuck with this, like.
But we have this fast way, like what Vite does, presumably with ESGo or ESBuild, is
ESBuild, yeah.
It can just ignore TypeScript and continue on. So it's getting out of the way in development time and not really slowing anything down, which is really good.
Yeah.
There's a few other things I kind of want to touch upon regarding these native dependencies. There are some certain kind of jobs that JavaScript can actually be pretty performant, because V8 is pretty amazing. Like if you write JavaScript code in the right way, you can get pretty close to native performance in certain cases. Because one of the things that Vite tries to do is we avoid full AST parsers during development. Like a lot of these features that we do, for example, we resolve your imports and rewrite them. We do that without doing full AST parsers. We use ES module lexer, which is written in C, to only find the imports. Then we rewrite those things using another package called magic string, which is super lightweight. It only do this sort of direct string manipulations without doing full AST transforms. So it's an order of magnitude faster than, say, parsing it with Acorn and then transforming the AST, then printing it out.
Is that because you're only looking for the imports? For our listeners, like I think when you're parsing, like when you're, let's say like const hello equals world, the string world, like when you're parsing that one line, like the first step is like, the compiler does is like actually just break that string up and try to find the tokens, right? So that's like the lexicon, right? So that's like, what is const? What is hello? What is this, the string, right? So like breaking that up, and then it goes into like actually parsing like the tree and whatever, creating that AST. So I'm just curious, like what's the benefit of the thing that you're doing? Like actually
parsing the whole file into AST is expensive.
Right.
So first of all, you have to actually parse, then you create all these AST objects, which creates memory, then there's garbage collection, and then you need to serialize the AST to print the transform thing. But if you're only doing, our only goal is to rewrite the import statements. So ES module lexer is essentially a shortcut that only looks for import statements. So it doesn't care about anything else. It looks for import statements, gives us their locations. So we can then look at those import statement sources, resolve them, rewrite them. So when we rewrite them, we use another package called magic string, which only do these really fast, simple string manipulations, like replacing a part of the string while retaining the relative positions of everything else and then generating a source map. So this is in fact the only transform that Vite does by default. Like if you don't use any plugins, this is the only thing we do, which is why it stays really, really fast. So we've been thinking about maybe we can replace magic string with a native dependency that does the same thing because it feels like a good candidate. And turns out someone actually did that. So they re-implemented magic string using Rust. And in the performance benchmark, we noticed that it's only maybe 30 to 40% faster than the JavaScript version. And for us, that becomes a much less attractive trade-off because the JavaScript version of magic string is lighter. Like when you compile something for native, it incurs another issue, which is distribution. Right now, for example, you're trying to download like Rust or Go, they all have to compile into native binaries, and you have to compile all these different artifacts for different operating systems. And then when the end user tries to install them, we need a way to figure out you only install the correct binary for your target operating system. And previously, it was a big hack. Like everyone is doing their own thing. Like you have to use a post-install script to like detect the target OS, then do a fetch yourself, fetch the binary, and then put it on the machine, which just sounds super sketchy, right? It's like a super insecure way of doing things.
Especially because it's not like we in the JavaScript community have the same hygiene around dependency management that folks who've been doing native development have, right? Like we just npm install stuff and like we're not expecting like, oh, I'm going to run this, like there's this binary that's compiling or whatever. Like, I mean, granted that does happen, but the whole point is like, we don't have the same hygiene around like low-level code running on our machine, you know, that like a Linux developer would have, for example, you know. So, but yeah, no, I'm just happy to hear that you have the same sentiment, you, Evan, like, you know, so.
This is one of the problems that the NPM ecosystem needs to solve next is like, how do we efficiently and securely distribute these native binaries if you want to actually make it easier for people to write JavaScript tooling with native languages? Because that's, from what I see, this is still kind of something that's lacking from the ecosystem.
Very much so. I mean, we're having trouble doing that with just plain old JavaScript, Evan. So like, you know, let alone the like native binaries. But I'm just happy, like Nick's probably heard me say this a bunch of times. Like I poo-poo on this, like, I don't know about Rust in the JavaScript ecosystem. Like I'm, you know, this doesn't make me feel good. Like I feel like the odd person out. So Evan, like, thank you for making me feel less crazy and less paranoid. And yeah, I'm with you.
Yeah.
So it's just to kind of like wrap up our discussion. Like we could talk about this for hours. Like what's your wish list, Evan? Like what are some things like that you're like eager to see land, eager to like some things on the roadmap that you're excited about, or some things that you wish you could change? Like sky's the limit, no boundaries here. So.
Okay, if there's one thing I wish we could change is if we can magically fix the Node ESM problem.
Yep, agreed. Check.
That would probably take some miracle, but that's probably my number one thing right now.
Mm-hmm.
Also, some of the legacy module headaches in the ecosystem that we've seen is like, actually, we've had this issue all along with Vite, is that some old packages in the ecosystem, they're like, we need to ship ESM now. So they ship in the ESM version, but the code actually contains require calls and like imports dependency that's still common JS and all that weird stuff. Like basically a mixed module graph.
Yeah.
And it just creates all sort of headaches. And these packages also don't really play well when you're trying to load them in Node's native ESM mode.
Mm-hmm.
Yeah, we've made a mess. We have like this mess right now with modules and in Node specifically, because it's just, things are clashing in weird ways because we've gotten really creative over the years. And like, I think this is just like it's not anybody in the community's fault, right? This is just like, we needed a solution for this much earlier, and like resolving, and like taking a train that's like going 90 miles an hour west and telling it to go 90 miles an hour east is like, that is not an easy feat, you know? So just like for what it's worth, like...
Yeah. Part of the reason why with Vite, we're like, okay, we're a new tool. So we try to push our users to say, okay, if you want to use ESM, stick to the packages that actually ship proper ESM.
Right.
we get a lot of bug reports about this kind of packages that like sometimes these authors don't even know they're shipping packages that have mixed module formats in them. So basically we try to tell the users, okay, you can let that author know they're actually shipping mixed formats. Maybe they can fix that so we can help move the ecosystem forward instead of asking us build tools to support these technically incorrect formats forever.
Right, because build tools also, like when we create that abstraction, we also create a crutch, right? Like,
yeah.
So it's like, let's fix the source problem. But yeah, I mean, that's the long tail of open source is also tough, right? Like there's no guarantee a maintainer is even still working on something that's still like widely adopted, right? So
yeah,
it's another challenge. And like NPM doesn't make it easy to like identify like, hey, here's the newer version of this thing that somebody forked and is maintaining. Like, there's no easy way to also redirect people to like the newer thing, you know? But yeah, so any other wish lists like before we wrap up? Like, are you like, everything is perfect with Vite?
Another wish list is if someone rewrites rollup with Rust. I know someone's already working on it. I just wish like they can finish it faster. But yeah, that would actually help Vite quite a bit, but that'll probably take some time, but I wish like that can happen sooner.
Rewriting rollup in Rust?
Yeah.
Oh, wow.
Yeah. So the idea, like I kind of forgot to go back a little bit regarding my stance on native tooling is I think we don't want to nativify everything.
The dependencies. Yeah.
I think we should nativify certain really, really well scoped important infrastructure projects. I think that's the right line, right? Something like Babel or Rollup, like these things that's the backbone of a lot of people's build stacks, where also you don't necessarily touch its code very often. I think these are good candidates to be rewritten with native languages because they would provide significant overall build speed or whatever for the entire ecosystem. But like if you say you have a tiny helper library and you write it in Rust, it's probably not worth it.
Yeah, no, I think you're right. That sounds like the right boundary to draw for sure. Like, and I think that's like a nuanced but important distinction. You're absolutely right. So yeah, I think it's hard to get that level of nuance out in the community though, because I think people like just there's a hype train going on. It's like hype. You know, nobody's like listening. So nuance gets lost. But it's fine. I'm confident we always find a way to do the right thing, always. So, you know, just good ideas float. So Evan, this has been like such a wow. I mean, it's 9 a.m. where I am, and I feel like I've already had like 8 hours worth of schooling. So like, but really thank you so much for like educating us and like walking us through some of the decisions that you and your team made.
It's a great conversation.
Yeah, really. Just, I feel like I've always been a fan from afar, and now I'm like, yeah, Evan, you're actually also a really good teacher. So please consider like doing more like just lectures, open lectures, like, you know, just Twitch stream your thoughts. I'll listen, like I'll be there. Okay, taking notes.
Agreed.
Maybe I should get into streaming.
Maybe you should. Yeah, see, you heard it here first, everyone. You know, you'll have me to thank for all your future knowledge. You know?
Be sure to like and subscribe.
Yeah, like and subscribe, exactly. You know, and we'll come up with like a French name for your stream channel. Like we'll have to think like, what would it be? I don't know. What's the French word for Twitch? I have no idea, but I'm sure we can find it.
I got it.
Are you Googling?
I gotta go to Google Translate again.
Google Translate, right. Yeah, so we'll put all the links in our show notes for everything we discussed today. There's a lot to unpack, so we're excited for you to dig into that. And with that said, it's been a wonderful show. And yet again, like, thank you to my lovely co-host, Nick Nisi. It's been a pleasure. And so we'll talk to you next week, everyone.
Likewise.
Bye-bye.
Bye.
All right, that is our show. Thank you for listening. What do you think? Let us know in the comments. Yes, you can comment on every JS Party episode on changelog.com. There's a direct link to the comment thread for this episode at the top of your show notes. If you're digging JS Party, do us a solid by recommending the show to a friend. We'd love to have them listening along, and hey, it'll give you one more thing to talk about next time you see each other. JS Party is produced by me, Jared Santo, with Breakmaster Cylinder Beats in the mix. Thanks again to our partners at Fastly for delivering this episode super fast all around the world. Next up on the pod, we are letting the segments recur. Allie, Amelia, K-Ball, and myself play a round of Story of the Week, followed by TIL, so you can learn alongside us, and I'm speaking with the author of Vest, a validations framework inspired by unit testing libraries. Stay tuned to jsparty.fm. We'll have it ready for you next week.
Bye.